This is Dr. Ian. For today, we're going to be working on solving some parts of a parallelogram given the conditions and properties that will help us in writing the equation to find the parts of the parallelogram that we're working on for today. In some cases, the challenge of answering problems in geometry is formulating our equation based on the clues that we have on certain polygons so that we'll be able to find the measurements of the angles or sides or diagonals that we are looking for in a certain type of polygon. And that is what we're going to be working on today, how to answer or solve for parallelograms involving its condition and properties so that we'll be able to come up with an algebraic equation that will help us in finding the measures that we are looking for. So in this particular case, we have a parallelogram, and in this parallelogram, we have L, M, and K as the corners of our parallelogram, and the point of intersection of our diagonal is P, and what we're going to be doing here is to find the measurement of diagonal KM and the diagonal LN. So we are given the measurements of LP, which is X, PN, which is y plus 2, the length of KP, which is y plus 10, and the length of PM, which is 2x minus 8. All of which happens to be an algebraic expression and not the actual measurements. So what we're going to do is we're going to rely on our conditions for a parallelograms, and we know that in our parallelograms, the diagonals of a parallelogram becomes a bisector, which means the length of KP and PM are congruent and length of LP and PN are also congruent, which is important because if we're going to find the measurement of KM and the measurement of Ln, all we need to do is to come up with an equation that will help us solve for the variables that we have right now. And in this case, we have two variables. That's why we need the system of linear equations so that we can find the values of x and y that will help us find the measurement of those diagonals. So let's start with the fact or the known fact that since we have bisectors as our diagonals, that means that KP is equal to PM. So we can come up with our equation, which is KM will equal to line segment y plus 10, y plus 10, congruent to line segment 2x minus 8. And that is the first equation that we have that will help us solve this linear system, because we know that LP or LN, is equal to this line segment, and we know that this line segment LP is congruent to PN, so we can come up with an equation for LN, which is x equal to y plus 2. And this is our equation 2. And by having these equations, what we can do now is use systems of linear equation to solve for our variables. We can use elimination method, we can use substitution methods. If you want to convert this into a matrix, Cramer's rule is also a viable option to use, but since we know that this type of linear equation would be best solved using substitution method, because equation 2, we already have an equation wherein x is already by itself, which is x equal to y plus 2, and what we're going to do is use that expression and find the value of y on equation number 1. So my technique right here is to use equation number 1, which is y plus 10 equals 2x minus 8, and replace x by y plus 2. So my new equation is y plus 10 equal to 2 something minus 8, and that something is going to be y plus 2. And by simplifying my equation, I can distribute y to the parentheses, and I have y plus 10 equals 2y plus 4 minus 8. And now that I only have one variable to work with, I know that by further simplifying this, I'll be able to solve for the value of y. So by subtracting y on this side, we'll have 2y minus y, which is equal to 1y. And by combining this 4 minus 8, we have negative 4. So what we can do is to add 4 on both sides. So we can cancel this out. And we'll have y equals 14. So this is now our first variable, and we're able to find the first variable by the substitution method in linear system because x can be replaced by y plus 2, and by further simplifying our equation, we're able to find that y is equal to 14. All we need to do now is to find the values of x, and if you can see equation number 2, we are explicitly given that x is equal to y plus 2. So let's just replace y by 14, and now we have x, which is equal to 16. So now that we have the two variables with their corresponding numerical values, we'll be able to figure out now the measurement of km and ln by replacing all our variables with x with 16 and y with 14. So let's clean our whiteboard and replace y and x with 16. And since we're looking for line segment km and line segment ln, we know from our equation that line segment km is no longer an equation, but it will be an expression wherein what we will do is to add kp and pm. And we know that kp is y plus 10, and we know that pm is 2x minus 8. So we'll add it up by replacing y with 14 and x with 16. So we have 14 plus 10 plus 2 times x is equal to 16 minus 8. And with that, we'll be able to figure out the value of our line segment LM, which is y plus 10 plus 2x minus 8. And by replacing our variables with the x and y values that we have just calculated, we'll be able to find the values of km, which is 48. And that is now the length of that diagonal that we are looking for. And let's complete it by finding the value of line segment LN by adding x and y plus 2. And we know that x is 16 and we know that y is 14. And using basic order of operation, we have ln equal to 32. And now we have our measurements for our diagonals with this specific parallelogram. So this is how we solve or use algebra to solve geometric problems similar to this parallelogram that we just worked on. So let's have another example and let's answer this quadrilateral. And this, according to the given problem, is a parallelogram. And we need to find the values of the angles, which is measurement of angle A, B, C, and D. Since this is a parallelogram, because it's explicitly telling us that we're working with a parallelogram, all we need to do is to figure out a way on how to find the actual measurements of those angles, because at this time we are only seeing an expression and not the measurements. So by using the conditions that we've had before, all we need to do is to use one condition that will help us in writing the equation that will help us find the values of x. And in this particular case, I'm going to use condition number 6, wherein it says the angles that are consecutive in a parallelogram is considered to be supplementary. And the key word here is supplementary, because supplementary means two angles, when you add them up, is equal to 180 degrees. And in this case, we can make use of that condition for measurement of angle A and angle B. So with this, we know that the measurement of angle A, if we add it up to the measurement of angle B, it will equal to 180 degrees because they are consecutive in a parallelogram. and measurement of A happens to be x, and the measurement of B happens to be 2x. So with this, we now have an algebraic equation that we can simplify and solve so that x will be by itself. So by adding this 2, we have 3x is equal to 180 degrees. And by dividing 3 on both sides, we now have x equal to 60 degrees. And now that we know our x, all we need to do is to use that value to find the rest of the measurement of the angles that we are looking for. So now that we have x as 60 degrees by using algebra, 3x is equal to 180. Dividing both of them will give us 60 degrees. So now we know that we can find the actual measurement of angle A right here, because all we need to do is to replace x with 60 degrees. And now we have the measurement of angle A, which is 60 degrees. And the next angle that we can work on is the measurement of angle B, which it says here twice of x, and x is 60 degrees, and twice of 60 degrees is 120 degrees. So now we have the measurement of angle B. And using the theorem or the conditions of a parallelogram, we know that angle A and angle C are congruent. So without even using algebra, we can now solve for the measurement of angle C using condition number 4, congruent angles in a parallelogram. Opposite angles in a parallelograms are congruent, so angle C is also 60 degrees, and we are seeing measurement of angle B and the measurement of angle D being opposite of each other, and it is a parallelogram. So that means the measurement of angle D using the same condition is equal to 120 degrees. So now we have all those angles. Forgive me for the quick shift, but we know that those angles that we have just calculated will be equal to those measurements using algebra and using the conditions of our parallelogram, which we are going to be using on the last parallelogram that you are seeing right now, because here we know that we are given the expressions for measurement of angle D and the measurement of angle B, and we are asked to find the measurement of angle A and the measurement of angle C. And using the conditions, we all know that in a parallelogram, opposite angles are congruent. So we can use that, so we can formulate our equation that uses the measurement of angle D and measurement of angle B, which is 87 equal to x plus 29 degrees. Now, since we know that opposite angles in a parallelogram are congruent, and we know that D is 87 degrees, without even doing algebra, we already know that angle B is equal to 87 degrees. But since we want to prove that that theorem is going to work for a parallelogram like this, let's see if this equation will give us x equal to 87 degrees. So we have 87 degrees, which is the measurement of angle D, equal to x plus 29, which is the expression representing angle B. By using algebra, we can subtract 29 on both sides, and x is going to be 58 degrees. And since x is 58 degrees, and we use that value of x for x plus 29, replacing x with 58, we can see that the measurement of angle D is indeed 87 degrees because they are congruent. And now that we have the two angles, we can now look for A and C using another condition. And in this condition is the same as what you are thinking. We're going to be using condition number 6 that tells us that consecutive angles in a parallelogram are supplementary, and in this case, measurement of angle D and angle C are supplementary, so it should equal 280 degrees. So let's come up with an equation that will help us find our angle C by having measurement of angle D plus measurement of angle C equal to 180 degrees. By replacing D with 87 degrees and using algebra, measurement of angle C is equal to 93 degrees. And now that we have the measurement of angle C, which is equal to 93 degrees, we can also find the measurement of angle A because it's opposite C, and it's also congruent with C. So angle A is also 93 degrees. So this is now our complete set of angles based on the clues that we have in this parallelogram problem. So for today, your number bender challenge is to find the measurement of line AO and line OC, given that AO is x plus 40 and OC is 2x plus 18. Use your conditions or properties of a parallelogram and come up with your equation that will help you find the values of x so that you can find the length of those line segments that you're working on in this number bender challenge for today. So comment it down below and let's see if you can find the measurement of the diagonals that we are looking for. And this is our lesson on parallelograms. And again, when we are working with some problems in geometry, sometimes we need to come up with our own equation that will help us solve for the missing parts of a polygon that we are working on. And in that particular case, we are training our brain to think analytically and critically, which is helping us to become more confident in working with any type of math problems that we're gonna have in the future. So this is Dr. E, and see you again next time. Bye!